In this video, I'll be talking about the relationship between F and M, or F at a D. So, as we know, a moment is a force at a distance. So, kind of like this, a force at a distance will create a moment. But the other way we can think about this is if we need both a force and a moment, as if we get like a force and a moment as an answer, but we want it in a force and a distance, we can actually do this conversion as well, because if we move our force to a distance, it will actually create this moment for us without us having to specify this moment. So the equation that we can use for this is in 3D, I should say 2D first. In 2D, our moment is just a distance at a force. That makes sense, right? We'll often be asked for the distance along a path, so we'll have to use a perpendicular force. Otherwise, you could do a perpendicular distance at our force that we need as well. That might make more sense to do a perpendicular distance at a force, is so that we can leave the force that we have or that we found from our previous work already. The other way that we can do this is in 3D, although it's a little more complicated because it deals with a cross product, is our R, which would be the distance in our I, J, and K, and our F, which would be in I, J, and K. So it'd be the same concept of getting a moment from a distance and a force, but this we just have to realize it's I, J's, and K's with the cross product. This is just perpendicular and multiplication. So that's this concept and this idea. Most of the time, you'd usually only do this when you got a force and a moment as an answer, and it'd be asking you for that force at some distance, just as another way of giving an answer. But it's the concept that you should be able to understand that the force at a distance is the same thing as a moment and a force.